In the last few videos, we talked about how we are leveraging these transformer neural network architectures to build these foundational models that can generate data. And that's fantastic. The only tiny bit of problem, which actually opens a whole field of research and actually implementation, is that how we get these models to leverage your data. And that's the million-dollar question, right? There are multiple ways that we can do. In previous videos, we talked a little bit about how we can build smaller language models, small large language models. But the most common way of doing this is retrieval augmented generation. At this stage, I think everybody's familiar with this. The idea is quite simple. I want to find the most relevant information, and maybe this exists in my data lake, data warehousing solution. Maybe it's somewhere outside on the internet. I want to give it to the model as the context. And of course, this is very interesting. On top of that, people are now building things called AI agents, which are these autonomous systems that kind of can figure out what is the ask and orchestrate relatively complex problem solving dynamics to generate the right answers. And I think there's a lot of value in that as well, especially if we see this alongside retrieval augmented generation or RAG systems. The third way of making these models better is to fine tune them. I honestly don't necessarily think fine tuning means fully fine tuning these models. In most cases, we are talking about PEFT, parameter efficient fine tuning, things like low rank adaptation, like LoRa. And the reason is we don't want to necessarily train these models with new setup, like pre-train them with new set of data or change all the weights of their network, because in that way they're losing, we can cause some sort of catastrophic forgetting. So what they could do, they cannot do because we over corrected with our data, and it's unlikely that we have that much data. So when we talk about fine tuning, we normally talk about parameter efficient fine tuning of relatively large models, right? Whatever we do, the most important thing is how to evaluate these models. One way is to use public benchmarks. I kind of talked about this before. It's very obvious why MMLU or HelloSwag cannot tell you if your system is working well in creating, summarizing some corporate reports. So they're really fantastic way using public benchmarks to see the overall performance. For you, they probably are not the best thing to do in your organization or for your public things. I find user testing the most powerful way of actually testing these things, whether like any other application. If we have them in pilot or if we have them in a production like environment, we can get people's feedback. It actually is very good in order to give us how these things are working. We actually can use those feedbacks to further improve the model as well, whether it's fine tuning the model with the feedbacks or using them to pass in context as part of in context learning. So that's the better way of actually evaluating them. Unfortunately, it might be not possible for everything. Sometimes we need to do this evaluation, human evaluations earlier, and that's where I guess we can. People are doing human evaluation as a separate thing, but not in production necessarily as we are building the system. Um, it's interesting because there are methods in there. It's not just like I give it to Mohsen, how was the response? So we're trying to figure out this model's output accuracy, coherence, relevance, and other quality metrics. So designing those evaluations is not really as simple as I give this AI infused application to 50 people and they tell us how they perform. So we need to figure out what metric we are actually assessing them on. And maybe more interesting way is how to use AI to evaluate my AI infused applications. LLMs judging LLMs. LLMs judging LLMs is one way actually to see the output of our applications. To be honest, I think it's very good way to start, but probably over time we want to use NLPs or smaller models to look at the output of our models because we need a very, very large language model to look at a large language model. That might not work very well. But initially, I think you can use very large language models to look at very large language models output. But eventually, what you want to do is to create systematic AIs that are only assessing specific things. and that can be done more effectively using NLP. Thank you very much for listening to me.